Couple of things. So we have this this preview of calculus that we're taking a look at. I wanted to show you something though, because I talked to my my colleague who is the reason why I'm using this system, the Lumen thing. It's new for me, so I'm adjusting. Thank you for being patient with me as I try to figure out what I'm supposed to do and how to do it, and you know, getting through some of the glitches. Uh, I won't give you 37 problems again, like I did the last day, whatever day it was. But one thing I wanted to point out is I was complaining to her about the lack of sort of help when you're working on a problem. So here's what I mean by this is I've got this here, and okay, let's just go ahead and pretend that I'm going to do this. And you can see like there's message instructor, and I don't even know what that does, to be honest. So that I guess it would message me, wouldn't it? But yeah, so that's all we've got. There's a video here, so we could watch this video. And I'm not sure how useful the videos are. Here's the video. Lovely, isn't it? Do I want to do this? Maybe. But you could do that if you want to. You can watch the video. I don't want to discourage you from doing that. But I guess what I'm disappointed with that was true of the old thing that I used is there's no links to the textbook, right? From, you know, like it would be nice if you're like, well, I don't know what to do here, but it'd be nice if I could just turn to that page in the textbook. So I did think of a workaround. So I don't know if you're into this or not. Maybe you're happy with the way things are working. But here's what I figured out that you could do. And I think this will work on most, doesn't matter what kind of computer you have, is so this is this practice of preview of calculus, and I've got the textbook section right above it. So do use those videos, the ones that are embedded in the homework. But I'll open this in a new window, and then I grab this, and you might, I know this works on Windows computers. I don't know if it works on Macintosh. You probably can do something similar. But if you push it over to the side of your screen, it'll allow you to do like a split screen situation here. And then I can have the textbook here, such as it is. And then maybe if I zoomed out a bit, it wouldn't be so bad. And then where did that homework go? I'm lost. Oh, this one, preview. There it is. Okay, so now I could, ostensibly, I could go back and forth from the textbook to the homework. And you can, at least on the, and probably the Apple, probably the Windows stole this from Apple. That's my guess. But you can, oh, thought it was supposed to move both of them.
It only does it sometimes.
Only sometimes. Okay, well, I thought I had it lined up. Oh, well. Well, now at least I can do this. Well, that's kind of useless. Well, anyway, do what you have to. Maybe if you have a second screen or a second machine. Like at home, I've got two screens, like something like this laptop, and then I've got like a monitor I bought on Amazon for, I don't know, 150 bucks. In my office, I've actually got two screens, one on each side, so I can have all kinds of things open. But do what you need to try to, to help yourself to do this. I'll try to figure out the whole message my instructor thing, see where that goes. I don't even know where it goes at this point. Maybe I'll ask my my colleague this. So with all that said, was there anything on this? Wow, that's so annoying that it's so, let's see, what if I do this? It's a little bit better. This is annoying. Can I get rid of that? That doesn't go away. What if I do F11? Yeah, that's better. Okay. Anyway, was there anything that you bumped up against that you're like, I don't know what that is, or I didn't understand this, or we didn't go over that in class? I'm going to do my best to go over everything, but like I said, I'm getting used to this system. So is there anything that we can talk about that you remember? Let's take a look at one that I want to look at, just to make sure that we're all on the same page. Also, so that sometimes I forget to bring the quiz. I actually have a quiz today. See, it's on the list, homework quiz. So I do have a quiz. So I want to make sure that we go over the one that's sort of similar to the quiz. So here we are. This one. Here we go. Yeah, this one. So let's just take a look at this one just to make sure we're on the same page in terms of working with these sorts of things. Let's see there. Okay, so this is asking you to compute the slope of secant lines between 2 points on a particular curve. And then at the very bottom, they say, take a guess as to what you think the tangent line of the curve, the slope of the tangent line is. So we're using secant lines to approximate a tangent line. And of course, if you use different points, you'll get different slopes. So here, maybe I can actually do this with a split screen. Okay. Right. Why is this? Oh, F11. Just a minute. If I do that, where's this? There's the iPad. Okay. Now I got to go find that again. Practice. Come on. I think I need to zoom out. Is that my problem? Yeah, that's a little better. There. I know it's like you're trying to deal with, I don't know, an elderly person, which I am, I admit. I believe I could get a discount now at Goodwill, which I'm so excited about because that's where I get most of my clothes, well, at least like my jackets, $5 if you need a sport coat. Such a good deal. Okay, but getting back to this, let's go ahead and do this one. So the point lies on this curve. So we have this point. Oops, let me do this. So this is the point 9.2. You can double check to make sure that they, no, sorry, 9.5. I misread that. 9,5 is on this curve. This is the curve y equals the square root of x plus 2. And we're supposed to find the slope of the secant line for these other points. So what I'm going to have to do is I'm going to have to compute. So for the first one, I have to find the value of y that corresponds with 9.1. And I'm just going to do this on my calculator. I just do the square root of 9.1. Okay. And then add 2 to that. So add 2. And I got 5.0166. And I'm sure that some of you are cringing because you can just also just plug this in as a function into the use the function y equals menu. But let's just pretend that you have a cheap calculator that doesn't have that feature. So you've got that, and then we just have to compute the slope. Slope is rise over run, so it's y2 minus y1 over x2 minus x1. I know that's a little bit hard to see, so there, that's better. So you're going to do 5.0166 minus 5 over 9.1 minus 9. So give me a sec here. And I got 0.1662. So that's going to be my answer for the first one here. 0.1662. And then this one, let me just go ahead and do that relatively quickly. So to do that one, the second one, I'm not going to do all of these. I'm just going to do those two. And then I'm going to cut down to this one just to make sure that we can do that one. So then that's going to be 9.01 as my x value. And I want to know the y value. So that's 9.01, the square root, plus 2. And I got 5.001666. And then if I do this divided difference, 5.001666 minus 5 over 9.1 minus 9, I get 0.1666. So that's going to be my answer there, 0.1666. Now, if you did this for the others, I didn't actually do this yet. Oh, I could just cheat. There. So if you do it for this one, you get 0.167 and a little bit. And for this one, you get 0.167 and a little bit as well. So there you go, or 1.667. And so if you had to guess what the slope of the tangent line is, it looks like these numbers are all just a little bit below 1/6, and these numbers are all just a little above 1/6. I know we're not all familiar with 1/6, but it looks like they're all crowding around this number 0.1666666. I'm just going to guess this. Let's just have my sixes go until I get sick of typing sixes, and let's see what it likes. If it likes my answer, can I get rid of this? Or is it going to want me to put a fraction in there? Oh, it liked it. So you could have done that, or 1/6 or what have you. So anyway, that's the sort of thing that it was looking for on that. And I have a quiz problem that's very similar. The context of the quiz problem is I give you a function for it's like the watermelon, but it's the same idea. So anyway, was there anything else from the homework? I know this is no one asked about this. Maybe everyone's apathetic, or you're still waking up. Zach?
I don't remember if it's the next problem or the last problem.
Let's go check.
It was that one.
Yeah.
How it took me like so long to figure out how to find B. Like it was really easy to find a slope, but I could not.
Yeah, so the slope is easy enough because you're just going to plug those numbers. Give me a sec. Oh no, I can't get it without. No. Okay, I'll show you the answer, but here we go. So the slope is apparently 31.6, at least for my numbers. Did you have the same numbers as me? Yeah, so everyone's got something different. So 31.6. So if you can find the slope, it's the same process. You're just going to take those 2 points, do y1 minus y0 over x1 minus x0, or x2 minus x1, however they're numbered. But here I've got my slope, and then I have to have a point. Oh, I guess I do need a point. So you pick one of those two. I'm going to use x1 is equal to 2, and I'm going to actually have to do the work now. Give me a sec. Trying to be lazy. 2.9 times 4 minus that, and I got y1 is equal to negative 0.6. So this is what I got when I plugged the x value into this function. So that's, you know how to do that. That's easy enough. So it seems like, I don't know, there's no better way to say this other than you need to go way back to 7th grade and remember your 7th grade math. And what I mean by that is back in 7th grade, you were given a slope, you were given a point, and you were asked, what's the equation of the line that goes through that point with that slope? So if you remember that, and I'm not saying you got to go back to 7th grade to say you should feel bad that you don't remember this. It's just that it's been a while. It's been a while since you had to do this. So back in algebra class, you learned how to do this. And there were a couple of ways you did this. One way you could do this is you could use what's called the point slope form of the line. The point slope form of the line is this: y minus y1 is equal to mx minus x1. So I don't know if that jogs some memory, like, oh yeah, that's something that we did. Another way is to use the y equals mx plus b and take these 3 numbers that you have up here and plug them in for y, m, and x, and then solve for b. So either way you cut it, you're going to get the exact same answer. I prefer this way, so that's the way I'm going to do it, but you certainly can do it this way. And to do it this way, basically you just plug 31.6 in for m, 2 for x, and negative 0.6 for y, and then solve for b. But let me just go ahead and show you how easy it is to do it this way. I do y minus negative 0.6 is equal to 31.6 times x minus 2. So that means that y is equal to 31.6 minus 63.2 minus 0.6. So I have to do a little bit of arithmetic. Sorry, this should be an x here. So then my final answer, and I know it's little, but I'm just going to have to scroll way up here. So my final answer is y equals 31.6x minus, give me a sec here, 63.2, so 63.8. So I just combined my 2 constants there. So apparently my value for b is 60, I hope. Let's find out. This will be, oh, interesting. They don't even have it in, that's so interesting. They don't even have it in the y equals mx plus b format. So they use point slope form for theirs. So they didn't even do it the way that they told you to. So apparently you can do it however you want, and just as long as you have an equation of a line. So good to know. You know, I've noticed this about some of these, so I'm glad about this, that you don't have to simplify. That's one thing. You don't have to expand things. So if you can express it, as long as it's algebraically equivalent to whatever it is that the answer is, you're going to be good. So, but my answer is the same as their answer. I'm not going to bother typing it in, but it's the same. All right, anything else? Yeah, we're going to use this because we're going to be interested in the tangent line to a curve. There's applications to that. So right now, it's all just like puzzles and games. Maybe you think of it as suffering and I don't know, pain. But we're just doing sort of these abstract exercises. Eventually, we will get to the applications. Don't worry, there are applications to calculus. We're not just doing this, well, we are doing it for fun, but there are some applications. All right, you want to try a quiz? I know you do. Now, I want to give you a little hint. So, because I know that one of the big complaints that I'll get from students is we will do something and then I'll give them a problem either on a test or on a homework or a quiz, and they'll say, wait a minute, we didn't go over this. And it's basically the same problem, just with like a different context. So I will make the connection for you up here right after I hand this out. So first quiz, this is the first one. By the way, you all got hundreds for your quiz score right now because I just, this morning, I looked and I saw that everyone did my survey. Thank you, by the way. I don't have the results for you yet, but I will bring them when I present them to my stats class. So everyone's got 100 for their quiz grade so far. And after this, hopefully everyone will still have 100. So, and if you don't worry. It's okay to follow a quiz or two. But this will be typical of what class will look like. Is we'll start with homework. We'll have a quiz that's about this long. This is about the longest I usually have for a quiz. Before you get too far into this, let me just relate this to over here. Give me a sec here, just so that you know this is the same problem as that. I know it's just a different context. So in my problem over here, I'm finding the slope. So here, this is the slope of the secant between t equals 1 and t equals 0. Sorry, not 0.5, 1.5. Yeah, that's. So in other words, I'm starting at t equals 1 and I'm going 0.5 seconds into the future. So I've got time instead of x. But other than that, it's the same. In fact, I'll even just do one more thing for you. I'll get you started with part A because I want to make sure everyone feels good about this. Is that for part A, we have the point 1. And when we plug 1 into this, what's that, 24? So that's t equals 1 plugged into this. And then, let's see, you're going to go from there to this point, 1.5. This I'm going to have to pull out my calculator. So I'll do this one, at least get it started for you, and then you'll do the rest. Oh, what? Okay. Apparently the height of this ball is 24 at 1.5 as well. So 124, go to 1.1, comma, you'll have to compute that, and then compute the slope. So I just want the slope for each of those. The slope is the same as velocity when you're talking about this context of position. So hopefully that won't be too harsh. There you go. And then if you are watching from home, which at least one person is, there's the whole quiz. You can try it, and hopefully you'll do well. Okay, my typical MO is at some point I tell everyone not to panic, that it's okay, but if you are done, just so I can get a feel for who's done, you can turn your paper over and sort of send it this direction towards the middle of the classroom. Don't panic though. You just don't want to spend all day if you're just doodling. I never know. Some people like to put nice pictures on the back, which you can do if you want to. That's fun. I'll get it. Now at this point, usually I'll start telling people it's time to panic. I'm just kidding. Still, you shouldn't panic, but try to finish things up because we do want to move on to the next task. Sadly, these fun things that I'm pulling out, those aren't your next task. That's the next class's task. Just wanted to get set up. You can look at them later if you want to. So let's see what we have. And then I generally go around and I look at your answers to see if I got it right. Because sometimes I get it wrong. And then if you ever see me like scurry back up there and fix my answer, that's probably because I'm like, oh, I forgot a place value. There it is. Great. All right, I'm not rushing you, am I? We're all done here? All right, let's do this. Excellent. So let's see. Looks like most of you got the same answer I got, which is exciting. So let me show you what I got. Wait, I have to turn this off. All right, so here's how I did it. So that I know it's a little bit messy here, but the first one, I gave you the 2 points. Just find the slope between those 2 points. M equals 0, easy enough. This next one, we go forward in time by 0.1 seconds. I was trying to, because it's the way it's written is a little different than the way that the homework was written. I wanted to make sure you understood that. Hopefully everyone got that. It looked like you did. So I go from 1 to 1.1. When I plug 1.1, I know it's a little messy here, but I got 24.64. So my slope was this minus this divided by this minus this. You can do, y2 minus y1 over x. It's like algebra. That's from 8th grade, isn't it? Or 7th grade? Whenever it was. You guys are all probably advanced students, so you had this early in your lives. And so it's understandable that you might have forgotten it by now. Here, I plugged in 0.05 seconds, so that's from 1 to 1.05, and I got an M of 7.2, and then I did the same thing for 0.01, and I got M is 7.84. Hopefully you're recognizing these numbers. Like I said, I looked through, looks like some of you have those numbers. And then the final thing, basically, I should have said it the same way that the book did, take a guess. There's no calculation here. You're just like, well, look at this. I get 0, 6.4, 7.2, 7.84. It looks like they're getting closer and closer to 8. But if you didn't guess 8, if it's close, you know, something like 7.85, I don't know. But 8 is a good guess. So if you guessed 8, great. If not, don't worry. You know, we'll see how you did. Look at that. You guys are doing great. Well, okay. Most of you are doing great. It'll be okay. I'll get this back to you next time. Okay, we do need to move on. So what are we doing? We're doing limits. We need a definition of a limit. So let me switch over here to PowerPoint land and find my limits. Where are my limits? I was doing them just earlier. Is this? Hold on a minute. I thought I was doing it this morning. Okay, this does not look right. Hold on a minute. This does not look like what I wanted. Well, you know, I guess we're going to use this unless, yeah, let's just use this one. It doesn't look like what I was looking at yesterday, but, you know, it'll work. I can fill in the blanks because we have stuff. So we're going to talk about the basic definition of a limit. Then we're going to talk about the limits on graphs and then limits using tables. So we're just going to do some basic limits. So the basic definition of a limit is just this. And this is kind of a cheater definition, but it works. So there's the symbolism that we're going to use. We're going to use LIM to represent limit. So LIM as x approaches a. So the way that I read this is I think of this as the limit as x gets close to a of f of x. So that's what I'm interested in. And to say that that limit equals c means that when x is close to a, f of x is close to whatever number, c in this case. Let me just show you an example of a limit. So before we go on, a limit that hopefully will help make sense what is going on here. So I guess I'm getting ahead of myself to limits using tables, but I don't care. I want to make sure that we understand what it means to be a limit. So let's pick a function, and I've got a good one in mind. I want to do the limit as x approaches 0 of sine of x divided by x. Now to do this, going back to this definition, what is a limit? A limit is what is happening to the function when x is close to a. So over here, on the one that I want to do as an example, I want to know what's happening to that function when x is close to 0. So to do this, what we're going to do is we're going to have you guys pick numbers, and then I'm going to do the calculations for you. So don't worry, I'm not going to make it. All you have to do is pick numbers. And here we go. Let's find Calc 1. Give me a sec here. Randomize. Sienna. Sienna, can you think of a number? Oh, it should be close to 0. 0.1. That's a good one. Okay. So what happens when I plug? So let's see. I guess I should call this f of x. F of x is sine of x over x. So far, so good. This is my function. And so I want to know what Sienna's asking me to do is she wants to know what is f of 0.1. Okay, I can do that on my calculator. Give me a sec. Make sure you're in radians because calculus is always done in radians. So check your mode. Make sure it's radians, not degrees. And if you're a physicist or an engineer, you're going to have to be switching every day. But just make sure you're in radians in this class. But anyway, f of 0.1 is going to be the sine of 0.1 divided by 0.1. And I got 0.998. All right, now I need someone else. Let's see, Allie. Allie, pick another number that's close to 0, but let's try to beat Sienna. Get something a little closer to 0 than Sienna's number. Okay, very nice. So what Allie wants me to do is she wants me to compute this number. Okay, I can do that. Let's try that. Let's see, 0.05. Whoops. And change this to 0.5. Give me a sec here. Okay. Oh, I pressed graph instead of equals. Let's try again. There it is. Okay, I got for Allie's number 9995. Yeah, that's kind of cool. All right, let's try another number. So you're not here. You don't exist anymore. Wait, Elena's here though. Elena exists. Elena, can you pick a number that's close to 0? Even better than Allie's number?
Negative 0.01.
Oh, I'm loving that. So negative 0.01. I was hoping someone would go negative, and it just took someone who's a little bit more negative than everyone else to pick a negative number. No, I'm just kidding. So we have the f of negative 0.01, but I can do this. I have the technology. So give me a sec. I just need to press this, type it into my calculator, because that certainly is closer than Allie's number. Make sure you use the negative. If you're using a calculator like mine, there's like a negative sign and a minus. So, ooh, 0.99998. Wow, it's getting super close. So the way I might arrange this as a table to illustrate the idea of a limit is I might do something like this. I would have my table, and on my table, I would have x and then f of x. And so let me just put these in order. 0, 5, negative 0.01, negative 0.5, 0, 5, negative 0.1. Maybe something like that. So 0 is right in the middle. 0.998, 0.9995. This is 0.99998. So in terms of the limit, does anyone want to take a guess as to what all these numbers are getting really close to? You can just shout it out. Yeah, it's just 1, right? Yeah, these are all really close to 1, and in fact, the limit for this is equal to 1. Now, here's the cool thing about limits, is that a limit isn't the same as a function value. Like, try plugging 0 into this function. I'll do it on my calculator just to show you. So I'm going to do sine of 0 divided by 0. You know what's going to happen when I press enter, don't you? It says error. Go to error. What's wrong with this? Oh, I'm trying to divide by 0. So I can't divide by 0, and yet there is a limit. That is to say, when you have numbers that are very close to 0, plug them into this function, the function values get really close to 1. So in terms of a table, you could do something like this to figure out a limit. But that's not the only way. I guess I've got it. I'm out of order on my graph, on my thing here. There is a more technical definition of limits, but we're not going to get into that because this is Calc 1, and we aren't going to worry about that. So let's try this. Fill in this table. I want to find the limit as x approaches 5 of x squared minus 4. And so I suppose, just a minute, I need to know what's going to happen when I click next on this without showing you. Oh, I see what's happening. Well, whatever. I guess I'll just do this one. This one's so easy. Well, no, I'll make you do the first step. So let's pick a number that's a little bit less than 5. And the number I'm going to pick is the number 4. I know that that's very far away from 5 compared to your numbers. Like Sienna went right to 0.1, and then we got negative 0.01. So all those numbers were really close to 0. But for 5, I'm just going to go down to 4 and maybe up to 6. So from 4 to 6. So start with 4. When x is 4, what is the function value? So the function here is x squared minus 4. So plug 4 into that function. And then Allison's going to tell me what she gets when she does that. You're going to plug 4 into this function because I'm saying 4 is close to 5. I know it's not really close, but it's close enough for me. So plug 4 into this. Yeah, what's it? 12. Okay, yeah, you can just do it in your head. Good. So that's 12. So there it is. So when you plug 4 in, you get 12. Now Ethan's going to plug the number 6 in just to show you that this works from either side. So when you plug 6 into this, what do you get? 32, very good. So you can see what I'm doing here is now what I'm going to do is I'm going to just get numbers closer and closer to the number 5 from either side. So when I plug 4.5 into that function, I'm not going to make you do this because you get all these decimals, but you get 16.25. If I plug the number 5.5 in, I get 26.25. Notice what's happening is that the function values are getting closer and closer to a special number. You probably know what that number is, but let's just go ahead and pretend that we don't. If I plug 4.9 into my function, x squared minus 4, I get 20.01. If I plug 5.1 into this function, I get 22.01. We're almost done. Let's just go to the end here. So do you see what's happening? What would the limit as x approaches 5 for this function be? What are these numbers all getting closer to? This one's coming from the top, this one's coming from the bottom, but what's the number in the middle there? These two, yeah, it's 21. I know it's so obvious, you're like, oh, it's too early. I should just pick you on my phone, right? Because you don't want to be self-selecting. Okay, yeah, we're going to say it's 21. And the reason why that limit is 21 is because all of the function values get close to 21 from either side. Now, in this case, I could have just plugged 5 into this function, but that's kind of boring. Well, it's easy, but it's kind of boring nonetheless. Let's see, are any of these interesting? They are interesting, but I only care about one of them, I think. And I think that's this one. Let me double check. Do I care about that one? Hold on a sec. I need to see. Maybe I care about more than them. Freeze and see what happens when I... No, that's boring. Oh, it's the bottom one that I care about. That's the one. Okay, give me a second. I'll just show you the first two. Unfreeze this. There it is. Okay, so let's do the first one. So once again, you could do this on your own, but the limit as x approaches -1 of that fraction, what you would do is you would pick numbers that are close to -1. It's a bit of a pain, so let me just do it for you. I should have had the table show up first and then the number. But if you notice on my table, all of these numbers, so I'm getting closer and closer to -1. And these numbers appear to get closer and closer to 0.33333. And then if I get closer and closer to -1 from the other side, that is numbers that are bigger than -1, they still get closer to 0.333. And so 0.33333 is 1/3. So these are all guesses. For this one, it's a similar situation, not all that exciting. Because all the numbers get closer to 1. You have to deal with the tangent, which is annoying. Don't forget to put your calculator in radians. But here you can see the numbers that are less than 0. When you do this, you get numbers closer to 1, and numbers bigger than 0, you get numbers that are getting closer and closer to 1. So I know, not super exciting there either. Okay, the last one though, this one is exciting, at least to me. So let's take a look at this one. So what I'd like you to do, is you can pick your own number. I'm not going to make you make a whole table. I do have a table I'll show you. But pick a number that is close to 1. And maybe you can decide, do you want to be bigger than 1 or less than 1? I don't care which. So if you go less than 1, pick a number like 0.9 or 0.99. Plug it in. Or if you pick a number bigger than 1, pick a number like 1.03 or 1.001, plug it in. And we're going to see what we get in just a minute. I mean, you could do 1.1 if you'd like. That's close to 1. So pick your number, plug it in, see what we get. All right, let's see how we did. Let me get a few of you to tell me what your numbers are. So let's see, where was I in my list here? I don't remember. But Zach, you haven't told me a number yet. What number do you have?
I used 1.001.
Ooh,
Got negative 0.0184.
really? You used 1.001? 2 zeros?
Yeah.
Okay, I think you may have miscalculated something. You may want to recalculate. Did you put parentheses around the denominator? All right. Yeah, I think you should get something different. Okay, let me pick another person. It's okay. We're just trying to gather data here. Kelsey, did you pick a number?
Yes, I did 1.4,
Oh, 1.4.
and I got 6.25.
Okay, that sounds reasonable to me. 6.25, good. All right, nothing against, well, actually, I do have something against X number. Sorry, Zach. Okay, let's see. Let me find the next volunteer. Not here. Ethan is here, though. Ethan, what number did you pick?
I did something wrong.
Okay, you did something wrong. That's okay.
Yeah.
Yeah, that's all right. But what number would you like to pick?
Oh, so I thought I was typing in 0.9999, but
Ooh.
I accidentally typed in 9. So.
Yes,
something very wrong.
0.9999, and then we could figure out what that is. That would be nice. Okay, so let's see. Where else do we have? Sienna, did you pick a number?
Yeah, I think I messed up.
What number did you pick?
I picked 0.99.
Okay, and what did you get as your output?
Like, I messed up. It said 10,000.
10,000?
Yeah. I don't know if that was right though.
I like that number. I like it a lot better than Zach's number. Okay, I'm going to go with 10,000. Something like 10,000. I'll just say it's like 10,000 because we don't know exactly. You're withholding information from me. It's okay. It's okay. It's a big number. Nonetheless, it's a big number. I'm happy with big number. Okay, let's see. We'll get a couple more here. Allison, did you pick a number?
Yeah, I chose 1.0001 and I got 100 million on the dot.
Oh, interesting. 100 million. Wow. Wow. So actually, I don't know if it's like 10,000. I think it is exactly 10,000, isn't it?
Yeah.
And you got 100 million. Okay. Here, let me get rid of this. Did you redo yours?
I did, and I got an even smaller number. So
Okay. At some point, I can teach you how to use your calculator properly. So here, let me just show you what I did. A bunch of numbers, including some of your numbers, but I can show you my numbers here. There are a bunch of numbers. So I did one. I guess I didn't do the 1.0001, but I did 1.001, and I got a million. But notice that the closer you get to 1, the bigger the number is. They just keep getting bigger. And same thing on this side. When you're going from the closer you get to 1, the bigger the number is. So whenever that happens, we're going to use this symbol. And that symbol there, the sideways 8, I know, you've seen that symbol before. That's the infinity symbol. And infinity is not a number. Infinity is the idea of growing without bound. So here, that symbol just means as you get close to 1, the numbers get bigger and bigger, and you think, oh, I must have made a mistake. But you didn't. You did get 10,000. Look at that. I got 10,000 as well. So I'm sorry to have doubted you or made fun of you. I couldn't remember exactly what my numbers were. And you got 100 million. I love that. It's so beautiful. So the closer you get to 1, the bigger the numbers get. And to express that, we use that infinity symbol to say that that's what's going on. Now, you don't always get a limit. So, and we haven't gotten to graphs. We'll get to graphs. Maybe we should let's do a quickie as to when you wouldn't have a limit, and then we'll get to graphs. So let me do this. Let's do this function. Do you know what that symbol means? The top absolute value, it's like if it's positive, you keep it positive. If it's negative, you make it positive. Okay, so I want to do the limit as x approaches 0 of this function. And so let me just pick a few numbers for you to plug in for me. So we have x and f of x. So we're going to start with negative 0.5, negative 0.1, negative 0.01. We'll just do those, and then we'll do the same thing from the other side, 0.01, 0.1, and 0.5. Just to compare, and I'll put 0 in the middle, but of course that is the limit, and you can't plug 0 into this function, so that's why we have to use a limit. Generally, limits are used when you can't plug a number directly into a function. That's the purpose of a limit. So go ahead and I guess pick one or more of these to plug this into, but after you do one or two of them, you're going to say, oh, it's always going to be such and such. So take a minute though, see if you can figure it out. All right, let's see how you're doing. Sam, did you have any more luck with this one than the other one? Or not Sam, sorry, Zach. Why did I say Sam? Zach?
For all the negative ones, I got -1.
Oh, interesting. Okay, so you're plugging in, you get -1, -1, -1. Okay, and then oh, I guess you did the whole thing though?
And then I got +1
+1 for all those.
Finally got 1 million.
Oh, good. You finally got 1 million. Okay, so I don't need to teach you how to use your calculator. Very nice. Okay, so take a look at what's happening here. If you look at this thing and you focus only on the numbers that are less than 0, then you would say, hey, look, the numbers are all -1, so the limit as you get closer and closer to 0 is -1. But then if we only focus on the numbers that are bigger than 0, then you would say, wait a minute, the limit is 1 because the numbers are getting closer and closer to 1. Well, they're exactly 1. So this illustrates the idea that we could have two different sides to a limit. So here's how I would express this. The limit as x approaches 0 from the bottom. So the negative there means from below. So like you're coming up from below, that's the negative there. So you put a little superscript on your 0, a little negative, and put an f of x. That would be -1. And do the same thing. The limit as x approaches 0 from the top. That's these numbers. And that ends up being +1. So one-sided limits. And anytime you have something like this where these two don't agree with one another, then this limit here doesn't exist. It does not exist. I'm too lazy to write out all those words, so I'm just going to write D and E for does not exist, but it doesn't exist. Ooh, we have 5 minutes. We got this. Actually, we have 3 minutes because I said we'd end at 8. Okay, so last thing, we'll do the graph finally, and then we will take a quick preview of the homework. Okay, so on the homework, you're going to see things like this. That's so hard to see. Let me just zoom in a little bit, or maybe I'll do it this way. And you'll be asked the question, what is the limit? So here we go. What is the limit as x approaches -2 of f of x using this graph? So using this graph, what you want to do is you want to find -2. Here's -2 on the x-axis. And so when you're getting close to -2, the function values, so here the x values, this is what's happening to the x values. Close to -2 means either here or here. But notice that the x values, as you're getting close to -2 from below, they all go towards this number 4. And when you're coming at it from the bottom, it looks like it's going to -3. -1, 2, 3. And this is 1, 2, 3, 4 here. And so this, the way that I would write this is the limit as x approaches -2 from the top is -3, because that's what the function values are doing. But the limit as x approaches -2 without a plus or a minus on it, that does not exist. Because notice that the limit from the bottom goes towards this number, from the I'm sorry, from the bottom, coming from this direction, you're getting towards 4. From above, which I know it feels funny because you're coming down here, but from above just means bigger numbers going towards the -2. You're going towards that point there. And so that doesn't exist. Let's see, there's a few others that we could talk about here on this graph. The limit as x approaches 0. So limit as x approaches 0, that's easy because notice that x equals 0. Here we go. Sorry, this is x equals 0. Close enough. And it looks to me like from the top, you're going towards -3. And from the bottom, you're also going towards -3. So because those two lines go towards the same point, since they're going from both sides, then the limit is -3. The other one that I wanted to point out to you is this limit as x approaches 4. So at least on my graph, I tried my best to express the idea of growing without bound. It's kind of hard, but so now we're growing without bound, so it's going towards positive infinity there. It could, by the way, you could have a situation where a function does something like this. So just one more picture to look at. I'll call this the number 2. So this goes down, this goes way up. So here the limit as x approaches 2 from the top is positive infinity, and the limit as x approaches 2 from the bottom is negative infinity. And the way you would distinguish those if you had something not a graph, if it was just an expression, is you just plug in numbers, and if they're getting bigger and bigger and bigger, positive infinity. If it's getting smaller and smaller, bigger negative, then negative infinity. Wow, so homework preview we don't have time for, but I bet you'll be okay. I previewed it myself this morning, and I was pretty sure that we would be able to get it through it all. I guess we kind of rushed at the end there, but hopefully it's okay. Do let me know how things are going. If you have questions about anything, send me email. I'll be around tomorrow during the day. Yes, Allie? From last night. Oh, no. All right, I'll come peek. All right, well, thanks. Oh, let me stop the recording so that